Hello, everybody. I hope this is working. If you're in the chat, go ahead and say something. My name is Garren, and I am teaching this class today. There's a whole bunch of different links that we need to go through to make sure that everybody's successful here. The first thing to keep in mind is if you go to tlk.io/PyLadiesRemote, hopefully you can hear me and see my screen. And here's where you can write something. So this is a good place for you to have conversations. We can chat about different things as we go through this PySpark workshop. This is an intro to PySpark. I should have mentioned that. We're going to talk all about Python and Spark, Apache Spark. And with that, you're going to hopefully learn how Spark works and how to use Python with Spark. Now, I'm not getting any feedback right now, so I'm a little bit concerned that this isn't working. So let's go with it is working. And let me make sure that everybody's got the right. I'm a little bit concerned that this isn't working. Now, what we're going to go through here is we're going to start by everybody being on this chat ideally, and the hashtag is hashtag PySpark workshop. Now, something to keep in mind here too is that I have another link that you should probably go to. Sorry, I keep grabbing that wrong window. Is I have all of this information, all the code, sample application, entire presentation on the site. On my site, it's the best way to get to it is garrens.com/PySpark124. And if you go to that link, it will direct you to this blog post. And in this post, you'll see all about PySpark or Apache Spark, a sample PySpark application, complete with walkthrough and explanations. And here's an important part. If you're joining us live today, custom built at Jupyter Azure Notebook. So if you go here, you'll end up at my library for PySpark intro. So this is an Azure Notebook that's hosted on Microsoft Azure. It's a free service that anybody can use. And I use this so that everybody can have access to the same environment that I have access to. And so I know that it works. This is how I built the whole class around. It's using this. What it does is it creates a free Jupyter notebook. I think right now they're having some trouble with creating notebooks because I think it's under too much stress. But anyways, go here and you can go to the link that's on my blog, and you'll get to the Jupyter Azure notebooks, which is right here. Now I'm going to make sure that nobody's okay. Good, Kathy can hear me. Good, at least I know that it's working. Sweet. So once you get onto here, ideally you'd clone it and then run it on your own environment. So you'll run it on your own notebook. So you'll have to log in. So I'm logged in right now into notebooks.azure.com. And so once you're logged in, you'd clone it, and then you'd be able to click the IPython notebook, and it would open up in Jupyter. Now, because Azure Notebooks is having some trouble at this exact moment, it may not when you're watching this video, you can also just download the whole library. So I'll show you how to do that in case you're interested. So here are all my different libraries, and I can click on PySpark intro and then hit download. Then down here, you'll see that there's, after a couple minutes, because there's probably like 150 or 200 megabytes worth of data in there, so it's going to have to zip it. So once it's zipped, it'll download for you. And so then you can just unzip it on your local computer, and you'll end up with a directory structure like this, where you have all of the files listed in here and all the different directories once you have that unzipped. So now, in my case, I'm running a Jupyter notebook, And with that notebook on my own, because I knew that that Azure Notebooks was having some trouble today, you can see that I was able to pull up my own notebook here. And now I can just click on PySpark intro, and the whole notebook will load up just the way that it should be doing on Azure Notebooks. I realize not everybody might have access to this same setup because this was kind of a last-minute curveball. I didn't expect Azure Notebooks to have trouble. It's been very good for me in the past. But because of that, we'll still go through this whole workshop, and you can run these things on your own, and feel free to ask any questions on tlk.io. Twitter, I would prefer not, because that's just more complicated. It's easier to work with TLK. So let's get started. Let me grab my presentation. So let's get started. So this is, as I said, Intro to PySpark workshop. I'm Garren. I'm your instructor today. I'm a senior data engineer, solution architect at Blueprint Technologies in Bellevue, Washington, just west of Seattle, or just east of Seattle, if you know where that is. Rainville, USA. My Twitter name is @G-Staubli, so feel free to chat with me. And as you can see on my presentation, at the bottom here, there's the hashtag PySpark workshop, but more importantly, there's the resources link. And so this is where you'll get everything that you need for this entire class. There's this entire presentation. I think I did make a couple edits. I'll have to add that to my site later, but nothing huge. You'll get the presentation at that link, all the different codes. So there's a sample application that's just a full PySpark application that we'll go through, and the full, like the big interactive Jupyter Notebook code as well. So all of that is in there. Kind of gone through this a little bit already. So everything's in there, and I would say the most important thing that you could actually get from that is all of the resources that I have put together for anybody who's interested in Spark, whether you have never used it before or whether you're pretty good with it and you want to get even better. There's really just a rich set of resources in there, and hopefully we'll get to that a little bit later. So do I know what I'm talking about? This is a fair question. Sometimes I have a slide that says, no, I do not, but I'm not doing that today. So I've been working with Spark since 2015. I've worked in the big data space for quite a few years now, and I really love working with data in general. So I've used Spark and Hive when it was still the most primary processing language for big data. That was like 2012, 2013. Used Pig a bunch. If you're not familiar with Pig, don't worry about it. You probably don't want to use it. And Hadoop MapReduce, which is still very common, but it's pretty legacy because Spark does everything better, usually by large amounts. I've built big data, real-time big data reporting using Spark with Apache Impala and CDH. It's pretty cool stuff. Some of it you can do huge amounts of data processing and do real-time analytics on big data very quickly. And building out a Spark structured streaming plus machine learning application right now for real-time decision making, so that we can take two different streaming sources from Kafka, join them together, do some machine learning. Just did a presentation on that too. If you're interested, you can look at my blog, and it has all the resources for that as well. And to top it off, I have 50+ answers on Stack Overflow for Spark so far. Now, the main points that I want to cover today are just learning about Apache Spark. We're going to go through a sample application so that you understand what's going on at the basic level, how it works. Then we're going to do an interactive Azure Jupyter Notebook. In that case, we're kind of throwing a curveball because it probably won't be able to get Azure Notebooks to work during this session. But if you're watching this later on, then you can try it. And if that doesn't work, there are ways. I think I even have on my blog a way that you can download a Docker image and run that as a Jupyter Notebook as well. And it comes with basically everything ready for you. I'm also going to give you some Python-specific Spark advice, because right now and really probably forever. Python is not a first-class language, if you will, for Spark. Spark was written in Scala. It is written in Scala, I should say. And it works the best with Scala. It also, because Scala has more functional elements and just functions differently than Python, just to put it that way, I guess. Python can be used very well with Spark, but it does come with some caveats that we're going to go over. And then resources to continue learning. I think that's actually one of the most important things that I can offer you, hopefully, because they're resources that I've personally curated. And hopefully you have faith enough that I can provide good resources there. So let's get to it. So what is Apache Spark? This may be a boring question, but it's also very good to know. Apache Spark is a fast and general engine for large-scale data processing. The whole point of Spark is to take what you're used to doing on one computer, on one machine, where you have, say, a pandas DataFrame, and parallelize that. If you think of it, I don't know if you're familiar with it, I can't really tell, but if you've ever heard of Dask, Dask is a very Python way of doing parallelized processing with Python. I can't speak to it as directly, but I can tell you for sure that Spark is a very nice way to do cluster computing. It's been around for a few years, several years now, and it's a very strong engine to work with. So on the actual computing front, when you write PySpark code, or when you write any Spark code at all, I should generalize this when I can, you'll see here that I have it listed as lazily evaluated, transforms versus actions. So right here, you'll see on this table, transformations, they're lazily evaluated. That means if you issue a command, and you'll notice that a lot of them look like SQL, and that's because SQL is fundamental to good high performance processing in Spark. It's not SQL that you're necessarily used to. There's actually ways to interact with Spark that doesn't look as much like straight SQL, because it's not a SQL string query, if you will. It's more of an API command that you can call. That's why there's camel case here, group by, instead of like group space by. But SQL is a huge part of how to get good performance out of Spark, because there's a lot of optimizations that go on underneath the covers to make it very performant. So the transformations, when you issue a transformation, you tell it you want to select some column, you want to filter out certain values, you only want the latest data, for example. All these transformations are lazily evaluated. That means when you hit enter and you actually tell it to run, all it's going to do is evaluate that your statement is syntactically valid and can be executed. It's going to create an entry in its history, its lineage, to figure out what it's going to run when you ultimately actually tell it to do something. Actions are what tell Spark to actually take an action, to tell it to do something with that, because transformations will return in milliseconds. Actions actually take time. So depending on what you're doing, they could return anywhere from hundreds of milliseconds to hours, days. I mean, there's no real end depending on what you're doing. And you don't usually want it to run for too long, because it's just more trouble if it's going to be running for too long, unless you're working with streaming data. So as you can see, I highlighted Spark SQL and Spark ML. I kind of modified an existing graph or an existing image that had the older versions of these same libraries before July of 2016. I would recommend, if you're paying attention, to avoid most resources from before July of 2016, at least from an entry-level perspective, because a lot of that stuff is considered outdated. A lot of it you shouldn't use. Any of the newer stuff after that date is what you ideally should use. So you want to focus on Spark SQL, which includes the actual SQL calls that you can make, and data frames and data sets. So in Python, you're only going to use data frames. You're not going to use data sets because data sets are really specific to both Java and Scala. Spark ML is the package that you'd use for machine learning. It's a fun one. I put together another presentation if you're interested in natural language processing, also on my blog. Has all has tons of code. Maybe I'll go through it in another PyLadies remote session some other time. So anyways, let's not get too distracted. Sorry about that. So everything in Spark, every command that's issued is immutable. That means that what you're doing is not actually changing the value of what's already there. You're just telling it to apply some new effect. So if you're gonna convert a date time to an epoch or a second since epoch, then you're not actually changing that. What you're doing is just applying a transformation. And transformations contribute to a query plan, but nothing is actually executed until an action is called. So let's go through the detailed architecture of kind of how this works. So you have a Spark application, the driver. We tell it to build with an app name of PySpark intro. Our master is local star. Sorry, this animation is a little bit ahead of me. So what that does is after you create you create this little block of code with get or create, and you hit run. This is going to build a Spark session, and Spark session is the primary entry point, and it's really the gateway to Spark. I'm going to use a little laser pointer. So Spark session is the gateway to Spark that you're ultimately going to use here. Now, the way that you work with that is then you can issue commands. The Spark session sits on the master, and you're going to interact with it from some machine that you're on. Now, when the master is told, when you tell Spark to do something, the master now is going to ping out and work with these slaves. The slaves are just the worker nodes. They're just an instance that you have in the cloud or on-premise. The point is they're a physical or virtualized version of an actual machine. They have CPU, memory, disk, etc. And within the slaves get built these executors. And executors are specific to Spark. It's a Spark concept where it's a Java virtual machine that gets built that ultimately contains all of your code. And that's how it actually runs everything you're trying to do. So an executor has an amount of memory, amount of CPU that's available to it. So for instance, you might have an 8-core worker node that gets virtualized, and you want to have a Spark parallelism of 2, because a lot of times you're trying to share a cluster with someone else. So those 8 cores become virtualized cores or virtual cores. So they might become 16. So you have 16 cores that you can work with, and you want each executor to have, say, 8 cores, and you want it to have about half the memory. So let's say you have a 61 gigabyte memory on your slave worker node and 16 virtual cores to work with. So you tell it, I want to use about 24 gigs of memory because you want to have a little bit of overhead available. You're going to have 24 gigs of memory assigned to each executor along with 8 cores. So now you can have 2 executors on that one slave worker. One each with 8 cores, 8 virtual cores, and each with 24 gigs of memory. So that equals up to 48 gigs, but then you have a little bit of overhead that you're giving to make sure that the operating system and the resource manager have enough space to work with. So when you give a task to, when you start to actually tell Spark, hey, I want you to grab this data set, do something with it, what Spark is going to do is issue out commands. The master is going to keep track of it. Think of it like an orchestrator. It's going to track what you're trying to do. So it's going to have the whole query plan of what you're trying to execute. And it's going to send all of the information about what worker node, namely what executor, is going to be working on what task at any given time. So Spark works in the concept of you have a Spark application at the highest level. Then you have jobs. So the jobs are specific units of the application. So you might have this big application that does all sorts of stuff, and you might have multiple jobs within that. Then once those jobs get distilled down, they go to stages. And so stages are just kind of logical units of execution. And then the absolute lowest level of how Spark operates is at the task level. And so tasks are units of stages, and they are the lowest individual unit of execution that you can work with. And really, you don't do anything with tasks. There are ways that you can manipulate how they're run, but ultimately Spark does most of that behind the scenes for you. The best way the higher level you go, the more you can change how it executes. So Spark SQL is not about SQL. It's about more than SQL. I grabbed this slide from someone else who had spoken about Spark, because it's really important to realize that Spark SQL is probably the most core part of how Apache Spark functions. At least it is for most use cases. There are some times when you don't need Spark SQL, you don't want to work with it if you're trying to do something very specific. But fundamentally, you do almost always want to use Spark SQL. And so another part of what to keep in mind here is when you're running in Spark, there are two kinds of actions. There's actions that are distributed, so they go across the whole cluster. You say you're saving some files off to HDFS, or you're saving them off to S3 or Azure. You're saving them to some database. Those actions do get distributed across the cluster, where each machine that you have in your cluster, so you have 10 nodes or 20 nodes, every machine is going to take part in running some individual task, then actually writing that out to whatever's going on in the rest of the cluster. Another type of action is a driver, are driver actions. And these I would recommend strongly against. It's very easy to get yourself caught in driver level actions that pull all the results back to your driver machine and your driver node. But the reason I caution very strongly against using these, and I do think they are good for sometimes, but just keep in mind the context of when you want to use these, is when you're pulling back only a very small amount of data. You do not want any more than a small amount of data coming back, because these must fit in the driver Java virtual machine. And that's a very small amount of headway you have to work with there. So don't try to do big data processing and pull back millions upon millions of rows or more than that with lots of columns, because you're just going to create a nightmare for yourself. But do use that when you need to, and it's especially good for Python, because if you say you have a few billion rows and you want to aggregate those down to like 500 summary lines that you then want to work with in pandas, that's perfect. You do a .2 pandas is the command on your DataFrame, and so now you can do your processing all in Spark and then pull it back to pandas to then work with in some later point. So bearing that in mind, we'll talk a little bit about the modern versus the legacy way of working with Spark, which I kind of already tangentially touched on. The primary area that you want to work with is within this colored box. I don't know what color it is. I am colorblind. But you want to work with all the things that are inside of here, namely Spark SQL, DataFrames, datasets. That's the primary API that we're going to work with, and really the only one you should use unless you really have some use case outside of that, because Spark SQL and DataFrames datasets are a big abstraction over the concept of RDDs. But critically, if you see in between Spark SQL and Catalyst Optimizer, or between Spark SQL and RDDs sits the Catalyst optimizer. So there's a lot of optimization that happens by using these 4 structures as opposed to these 3 on the right side that are more outdated. Still can use them, just you will run into more issues because some of them are not as developed anymore. Like MLlib will eventually be, I think, deprecated entirely. So try to stick within this concept so you can work within the optimizer and really just within the more modern space. So now let's walk through a sample Spark application, complete with code. So we're going to first build up our Spark session so that we have our gateway to everything in Spark available to us. We're going to assign a variable. We're going to use the Spark session.builder after we import Spark session from our namespace of PySpark.sql. We're going to give it a name of PySpark intro. Our master is going to be local star. What we're telling it here is just we want to run it locally on our machines, that our driver is our executor. It's kind of a funky way of doing it, but we don't want to run this in a cluster just yet. But I also note here that there are other deploy modes, of course, where you're going to do standalone. You're going to use Yarn. Yarn just stands for yet another resource negotiator. Mesos, or the newest one and the most fun one, of course, is Kubernetes. That will continue to be developed. This one is the most currently in development in terms of just kind of being a beta product. So once we've set our master, we're going to get or create, which just tells it to actually build the session. Because funny enough, everything before here is more or less lazily evaluated, like most of Spark. And once we have that session, we can then kind of look at it. And so here's just a screenshot that I took that shows we have an in-memory Spark context. Spark context is the prior word that was used and prior namespace for Spark. That was an entry point, and Spark session has taken over everything Spark context used to do, but Spark context is still available and it's still used heavily within Spark. And then once we have the session, we can also see that there's a UI that we can play with. We see the version is 2.2.1 in this case. 2.3 came out. I've talked about that in other parts. You can also look at my blog there because there's some cool stuff that's actually really important to Python. You have pandas UDFs that use Apache Arrow that make UDFs much faster in Python because they're vectorized instead of line by line, and it's just much more performant. I'm not going to go into that there, otherwise I'd just get distracted. Our master we set as local star, so we're just using all the cores. That's what star indicates in this case. And the app name is PySpark intro. So now let's say we want to read in some data. And this is a data set that I also use in my intro IPython notebook or Jupyter notebook. It's just Greentrip data from June of 2017. This is just data that I pulled from the New York City Taxi and Limousine Commission. It's free, it's available. I use this one because it's smaller, which is something to keep in mind, because if you're working with trying to do big data but only on one machine, you're not going to be doing big data probably. So this is like 84 megabytes or so. And this is totally reasonable. It can run. And on Azure Notebooks, this is probably kind of up there in terms of if you want things to run within a few minutes. Because on Azure Notebooks, you only get 2 cores and I think 4 gigs of memory. So you can't expect a whole lot because you're getting it for free. But if you're running something in a cluster and you have tons of machines at your disposal, each one with 60 gigs and 8 cores of physical cores, 16 virtual cores, then you're probably going to use a data set that's much, much larger than 84 megabytes, and it will run very quickly still. But now that I'm done with that tangent, let's go back to the actual code. So we're going to tell Spark to read. This is the way that we're interacting with Spark, is spark.read. We're not going to do any of the old style. In fact, I'm not even going to mention it so we don't get caught into that rabbit hole. So spark.read, then we're going to pass in an option. We're going to tell it has a header. So this is stuff that you have to specify with Spark as opposed to like pandas, which assumes this more or less by default and does its own introspection into the files. So it has a header, and then we're going to tell it, this is a fun line, we're going to tell it to infer the schema, and we're going to pass true. And so you'll note here that I say that this forces eager evaluation. The default for infer schema is false. Now, what that means is, like I said before, everything in Spark is lazily evaluated, except for actions. Like the English language, there are exceptions. In fact, in English, there's more exceptions than there are rules, it seems like. But what we're doing here, normally this would be considered a lazy action. We're just telling Spark, hey, I want you to go to this file, make sure that this file exists, and just go read it. But we're not actually telling it to actually do the reading normally, because infer schema, when the flag is false, it just assumes that every field in this file, every column, is a string. But when we tell it to infer the schema, we actually want it to figure out the exact data type that each field is. And so that means it's going to have to actually read through this file to understand what data types are in each column. So after we do eagerly evaluated with infer schema equals true, you'll see that I had highlighted all the different data types that each column has. And you see that there's a vendor ID and drop-off location ID, pickup location ID. And you'll see that these are integers. There's some timestamps, some strings, some integers, some doubles. So you'll see that it's a nice diverse mix of data types that are much more helpful than just all strings. But if we did it lazily evaluated, where everything's just a string with infer schema false, you'll note that every single data type is just a string, which is not very helpful when you actually want to do a lot of this stuff. So there is a way within Spark. This is kind of a really fun way to work with it. If you're more comfortable with running SQL queries, you can just call greentrips.create or replace temp view and pass in a string greentrips. And so now you can actually run any arbitrary SQL query that you want. So now you'll see that I'm going to create this new variable, revenue by hour, equals spark.sql. And so what spark.sql does is it takes in a big string. So from the first start of the quotes here to the last quotes here, everything here can just be a regular SQL statement. So we're going to get the hour from the pickup date time. We're going to name this column pickup hour. We're going to sum the total amount of just how much revenue we got for that hour. It's just kind of a silly query, but it could be useful. From Greentrips, that you'll note that's from when we created or replaced the temp view. So this just makes that available as if it were a table or a view that we're more traditionally used to with relational databases like MySQL, Postgres, Oracle, SQL Server, etc. And then we're just going to have to do a group by pickup hour. That's right here. So we can do this sort of hacky way, or nice way, I guess, of being able to use the new column name that we just created, which was pickup hour. Then we're going to just order by pickup hour ascending, so that we can look at from hour 0, which is midnight, to 23, which is 11 p.m. of that day. So we can see how much money we're making per hour. Okay, so actually, sorry, let's finish here. So once we pass this command, this whole SQL query to Spark SQL, it's still going to be lazily evaluated. And what you get back, what this variable will contain, the revenue by hour, this revenue by hour will be a Spark SQL data frame. So it's as if you had run code directly on using the API. So like if you did a .group by, .order by, etc. The command that ultimately gets created and the query in the query plan would be the same as if you had used SQL or the APIs that are within the language. But the cool part is you get to work with a data frame again. It's not like you have some new structure that's abnormal. So once we have our revenue by hour and we want to write it out, because so far this Spark SQL that we're running here, this is just lazy evaluate. It's not going to do anything if this is all we do. We're just going to have, Spark's going to know what it needs to do, but it's not going to do anything. So say we actually want to write it out. We're going to tell it to overwrite the directory, and it's going to write to a CSV. And so green revenue by hour now, this is going to be a directory, as I note here, with multiple files. So even though you might say .csv and green revenue by hour, and you might even put in, because of just habit, you might put in a .csv at the end there. So even if you did that, even if you did .csv here, it doesn't matter. Spark will still write this out. I probably should not use pens. Even if you did that, it would still write out to multiple files. And that's just because remember that you're sending all this work through a cluster. If you wanted it to write out to just a single file, you'd have to bring it back to the one machine that you have, your driver, collect it, and actually write it out using Python directly or pandas, for example. And so now we can see here, I printed out kind of an example of what this might look like. You have this directory, green revenue by hour. Let me see if I can clear that because that's kind of ugly, looking at that handwriting. No, that was really not helpful. So you have this directory that has green revenue by hour, and now I feel like I need to get out of that. Okay, that's going to drive me crazy. Green revenue by hour and all these part files. So part files is just how Spark writes out. You'll notice here that there's part 0000. It's 5 numbers, really fun to say. And then there's 1, 2, 3, blah, 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 until you get to 23. So there are 24 total files in here. And then you'll notice that there's a UUID. And so this is what Spark does underneath to make sure that there's no collisions in when it writes out. And just to overall, it's good for execution purposes. It used to be that we would write out to just part-00.csv directly and not have a UUID. But it's good to have that because now you can run it, you can have mode write, mode append instead of overwrite, and it can write from multiple jobs to the same directory, and there won't be any collisions because they'll have different UUIDs. Now, behind the scenes, when you run a command like read a CSV in and do something with it and write it out, there's a user interface, a UI, that lets you see what it's doing, including a directed acyclic graph to understand more of what it's actually doing underneath. Sorry, I'm a little bit ahead of myself. I forgot what all the slides are, and I don't have presenter view on. So underneath, we can see that it read in a CSV, and it took 5 seconds total. We see our tasks for all the stages. So these are the job IDs. There were a total of 1 out of 1 stages. We got success for both of them, both of these, which is great. That means that we didn't have any failures because I wanted to get you hooked on Spark and then drop the bomb that Spark is a really big pain in the butt to troubleshoot. On that note, we are hiring. We are based in Bellevue, just east of Seattle, bpcs.com. And that is the end of the presentation part, but that is far from the end of the actual class today, because now we're going to move on to the more fun part. Hopefully, let's see if there are any questions. I probably should check this. Reminder, okay, yep. So if you participate, you can possibly get a free JetBrains license, which is awesome. Okay, perfect. So no questions there. Good, good. Just quickly check here, make sure that we're not relying on much here. Okay, good, good. Sorry. Now, if we go to the actual code, we can see, so this is in our PySpark intro, Python notebook, or Jupyter notebook. Point is, it's Python code that does all the stuff we want. And in here, we can see that we're So this code, I built this all in Azure Notebooks. And I haven't really run this on my own computer because you'll note that I'm on localhost because I'm using my own Jupyter Notebook locally. But this code should fundamentally work just fine on your own local computer. It's just going to run pip install PySpark. If you don't have it already, then it's going to actually go and download that, install it, all that fun stuff. You'll notice that it installed PySpark 2.3, which is awesome. There's lots of fun stuff, as I mentioned in there. Then we're going to download all the different files that we need. So we're going to go to the New York City Taxi and Limousine Commission, download the Greentrip data, and it's just going to write out to the local directory. In my case, that is right here. It's in my, I'm a big Linux user, Mac user, obviously. You know, big surprise. So it's just going to write out here, and so now I can see that I have all these different files. I've already run this stuff, so obviously I'm cheating here because I don't want to rerun it because I don't really feel like waiting for it to download. And so we're going to download also the taxi zone lookup so we can do some joins and do some fun stuff. Then because we really like to have fun, or at least I do, and I'm sure most people do, we're going to import some special SQL magics, and because it's awesome, and they're called magics, and these are awesome because they make it much easier to run interactive queries and get them formatted back in a really pretty way. So I love this stuff. Makes it much easier to work with in an interactive situation. These I just copied from, yeah, wherever this is. Thank you, Luca Canelli. Then the main part here for us is we're going to just go ahead and import a bunch of stuff. I did not abstract this out into separate places in this class because I want you to see how I do all of this. In at least some of my other classes, I do abstract away some of these kind of housekeeping items, but we're not going to talk about that as much. We're going to focus more on what's actually going on. So we're just going to create our Spark session again using the same information we had before. And now you can see where I did my screenshot, so fancy schmancy. So now you can see that I have a Spark UI, but I'm not actually going to click this because it's not going to work because that's just the way that life is. So once I have my Spark session, I have this context and I can ask for the web URL. I'm not going to run this either. I really probably should either try to run this and see if the demo gods like me enough. Let's go ahead. I don't see why not. So it seemed like that worked. That's cool. I'm always shocked when things work that easily. So cool. So far we're 2 for 3. Let's see if 3 for 3 soon. We're just going to try to create our session and do some fun stuff because we like to push our limits with demo gods. Oh, cool. It looks like Kathy's been able to get the Azure Notebook working. That's awesome. Good job. I'm glad somebody's got it working. I'm going to keep running it on my own local notebook because I really don't feel like testing the demo gods that much. But now you can see that I have my own Spark UI, and now it might actually work. Ooh, do not leave this site. No, please don't do that. Yes, it does work. Sweet. But if you're using the Azure Notebook, I will warn you it's not going to work. Unless they fixed it. I put in a bug months ago. I don't know if they're ever going to get to that. They don't seem to want to fix that for me. Then we're going to go ahead and just register a jar so we can use some of the Hadoop AWS syntax and be able to work with it. I don't think I ever actually use this, truthfully. In fact, this is a useless thing to do now that I realize it. In fact, I think I knew that, and I think I was trying to show that this is not a good way to do it because it looks like a good way, but it doesn't actually do anything useful. I think I must have made notes somewhere else on that part. Don't ever do this because you're not actually going to be adding a jar to anything useful. You can't actually use S3, for example, just by importing that. So that's terrible. Let's just get rid of that because that's just going to cause problems. Now we're going to run that process we had earlier, which is just going to actually go and go and create our data frame in a eagerly evaluated way so that we can have our schema, and we're going to print out again, and we can see that there's all the same fields we had before. But because this is a live demonstration, I might as well test my luck a little bit more. And you'll see that I had purposely timed this cell so we could see that the wall time was 7.72 seconds. And if we look back at PySpark intro, you'll see that now we have 2 jobs that ran, each with 1 stage. This looks identical basically to the version that I showed in the presentation. And critically here, it's great. That means that it did what it was supposed to do. But because we can also play with this, well, let's see how long it takes if we run it not eagerly evaluated, and we only get strings back for our columns. You'll see that it went from almost 8 seconds to 192 milliseconds. And if we go into here, you'll see that it did effectively nothing useful. It just said, does a file exist, essentially. In fact, we can just jump into here and we can look at the DAG. It's not doing anything useful. Whole stage code gen is great, but in our case, it's not very productive. And so that's terrible because now all of our fields are string values and we just don't want that. So let's go ahead and run that again with eagerly evaluated so we can get everything back. And you can see that the wall time actually went down the second time we ran it. Spark and really any JVM-based system will tend to have a good amount of overhead, and the more you run things, the hotter and faster it gets. It helps that I'm running this on my laptop because I've got a pretty nice SSD and some good memory. So anyways, now we've got our data frame, and this is our schema. And we're going to go down and actually run this cool fun stuff because we like fun stuff. So what this is going to do is going to create that temp view that we had before in the presentation, but this time it's actually going to do it. Then we're going to run our SQL command to get the revenue by hour. And then we're going to throw in a little curveball fun one where we're going to do revenue by hour.cache.count. And in Python, I should note, you do need to have the parentheses. I also write a lot of code in Scala with Python, with Spark, which I truthfully prefer Scala with Spark, but Python is my second favorite, and it's pretty close to Scala. Part of what drives me crazy about Python is that it forces me to always use parentheses, which drives me crazy. And I just realized I said crazy twice, so I'm definitely going crazy. Now this is video recorded, and I can laugh at myself later. So what we're going to do is just cache count. So what this is going to do, cache is lazily evaluated, so it's not going to actually do anything on its own. It's just going to tell Spark, hey, I want you to cache this. And one of the reasons why Spark is so fast is because Spark lets you heavily use memory and rely heavily on memory, which is awesome, because if you can keep something in memory, especially when it's only 24 records and it's only 2 columns, that's negligible. That's basically a rounding error, not even, for the machine. But then I call .count, and so now I'm forcing evaluation. It's no longer just a lazily evaluated like cache is. Count is one of those actions. So it's now going to actually force it to run, and we can verify that by going to our Spark UI, bouncing over to Storage tab, and you'll see that I have this huge RDD name, because it does eventually become an RDD, and it's only memory deserialized. You can change this. I'm not going to even go into that today because that's a whole different topic. We have some partitions. In our case, it's actually silly because it's caching with 25 partitions. So at least one of those partitions is empty because we only have 24 hours. 100% of this data frame has been cached because I forcefully told it to cache, whereas normally if you do caching on a data frame, you can then work with it'll only actually put it in memory when you start to use those pieces. So you might only look at hour 5, and once you look at hour 5, it's going to actually cache it. But we didn't do that. Size of memory is 8.2 kilobytes. There's nothing on disk because this is small enough to where it didn't need to go to disk. And you'll see that I put the same screenshot here at an earlier time. So even if you don't have the UI available, because if you're using Azure Notebooks, you probably don't. And if you do, then I'm jealous. Because I was never able to get that to work. Also, if you do, tell me, because I want to know. So once we have revenue by hour, we can also run, and this is DataFrame, remember that? And we can do a dot explain. So explain is just going to show us, just like we would run like an explain statement in a SQL query, we can run explain on a data frame, and it's just going to give us an idea of how it's being run. So there's an in-memory table scan, it's got a sort, exchanging, and then we have some aggregations that are going on, and we're reading from a file. So yeah, pretty fun stuff. This, you don't need to worry about this until you get a little bit further in to Spark. Then when we actually want to do revenue by hour and we want to write this out, we could uncomment this, and we're going to do write.csv. And so this is just going to write to a directory. Green revenue by hour is the directory, and that's right here. So we can see here that we have all of these files have been written, all the part files, .csv extension. I will note, because I don't see why not, a lot of times people will like to do compression of some sort. So the way that you do that is you pass in an option to the DataFrame writer, and you're going to tell it option compression, and so you might say like gzip. So if we were to do this, I'm just going to do this so we don't have collisions. I think yeah, okay. So let's go check that out. So now we have green revenue by hour, gzipped. So now you can see that our output files, we've got a bunch of gzip files, which is great if you're doing something where you need that. And because I like to have fun when I like to do live coding to some extent. Call me a masochist if you will. So we can also repartition the data frame. So if we want, say, only one file to be written on the output, then we can tell it to repartition to one. So now do note that we're still going to have a directory that gets created, but in this case, it's just going to have one output. So if we're going to also change the mode, we're going to overwrite, because we already have that directory, and I don't feel like deleting it in the command line because that's too much work. So now we're going to rewrite this, and so let's just clear that. And so now you'll notice that we have one single file that gets written out in return. And because, like I said, I like to cause myself trouble because trouble's fun, I'm going to show you a way to do this with pandas. So you could also do a .to pandas. So now you can see we have our hour, which I, silly enough, never renamed that column. Oh yeah, I thought I did. Whatever. Let's not worry about that. Yeah, whoops. Take out the hour. Why not? I tell myself not to worry about it, and then I do it anyway, so that's good. So there we go. I got that. Now I run this, and I hit pick up hour. So this is just what you're probably used to. All you people who use pandas a lot, I used to use it a lot more than I do now. I love pandas, though. It's just I work with Spark a lot, if you couldn't tell. So now we can just do like a .to CSV. And now we can say like green rev from pandas.csv. And now we go back to our notebook, or our terminal, and you'll see that we have somewhere in here, here we go, cat green rev. So now we have our pandas output. So there you go. You got a little bonus for tuning in live. I can show you how to use two pandas, even though you probably shouldn't do that if you have big data, like I was saying earlier. Okay, we're still good there. We're still good here. Awesome. So then I just did an LSALRTH. I'm a big fan of this particular way of doing it. I have it aliased LA myself. So this just shows us all the files. Oh, apparently I did do a pandas version of this. Oh, that's hilarious. Well, then sorry, you didn't get a whole lot out of tuning in live. But who cares? Happy you're here anyways. So like I said before verbally, but if you're more of a visual reader, visual understander, Spark jobs are distributed and writing is done by each executor when using Spark's write API. So calling two pandas is not free and will throw errors on larger data sets because the single driver machine now has to hold the entire data set in memory. You're welcome for reading those and I'm hopefully doing a good job of either entertaining you, putting you to sleep, both. Okay, so once we have all that lovely stuff, we can also display the result of Greentrips. So we can just go back to our original data frame that had all the data, not summarized in just hour and amount. And we can just sort it by random, because sometimes I just like to look at my data and just do a sanity check to make sure that it looks right. And random sorting is a really good way to do that. I should note that this is also the f variable here is coming from my import statement right here. So we're just importing functions, which is part of PySpark SQL. There's a ton of really, really good functions in here that I strongly recommend you use in the most direct way possible, because if you use PySpark functions, SQL functions, you'll get the most performance out of your code. Because they're heavily optimized, and ultimately they don't actually run in Python at all. They run in the Java virtual machine, likely via Scala. And so the performance is crazy, and they're way better than if you try to write a UDF, a user-defined function that uses Python. But that does partly change it. You still will probably never beat Scala and Java in the JVM, even with your own Python UDF. Even in Spark 2.3, where you have pandas vectorized, because still you have to deserialize. You have to still pass data around a lot more than if you just use the data that's already in the JVM. Whew. All right. So Greentrips, we can just look at this and we can see how many partitions our file is in. Because one of the beautiful things about Spark, of course, is that it's distributed. And what that means often is when you use the right type of file, you can have multiple cores working on different parts of it. So you can have one core doing one part of some big multi-gigabyte or terabyte or more even files. Although you really shouldn't have terabyte plus files. It's kind of obnoxious. And I should note, because this seems like an opportune time to note, when you do something like use gzip, which is a great compression format in some ways, because it's very it's widely used, it's widely accepted, well respected, it's got okay performance, but it at least uses really low amounts of disk. There's a huge cost and a caveat to using it. Gzip is not splittable, which means if you have, say, a gigabyte file and it's gzipped, you have to wait for one single core on your machines across the entire network. So if you say have 100 cores or 80 cores dedicated to doing all your work on Spark, and you have one single 80 gigabyte gzip file, it will not be parallelized. It is going to go and have to decompress that entire file on one core. So please do not use gzip if you want good performance and you have just huge files. Try to keep gzip files, say, under 50 or 100 megabytes. But don't go with small files either, because small files are even worse of a problem, where you have thousands of like kilobyte files. Those are like the absolute devil and bane of existence for anybody who works with data. So I'd rather see you use a big gzip file than millions of tiny files, because I've lived through that pain and live through it regularly still. Let's see if anybody's commented on all my ranting and raving here. No, that's good. You guys are asleep, or I'm not ranting and raving enough. So then we're going to go ahead and create our taxi zones, which we're going to follow the same structure as we did before. So let's just run it. We're going to just cache and count it, because I know that I have enough memory available, because it's a whopping 7.4 kilobytes. So I'm not going to lose sleep over that. So then I'm just going to create these pickup zones and drop-off zones. And this is just my way of, I'm a data engineer, so I do this type of stuff all the time. This is just a way of making it so that I can work with pickup and drop-off much more simply and not have to use one data frame to do it. It's actually easier to use multiple here. So we can look at our Greentrips with locations. So what we're doing here is we're going to first do a join of the actual Greentrips, and we're going to do it to the pickup location ID. So if we look over here, we can see that the pickup location was in the Brooklyn borough or Manhattan or Queens. The zone was Williamsburg. I don't even know any of these places for the most part because I'm a Seattle area person. And then we the drop-off borough, zone, and service zone were all these lovely places. So that's after we did both of our joins, which is important because if we did only one of those two joins, then we would only have the pickup information or the drop-off information. Okay. So then I'm going to create a replace attempt view again, but this time it's going to be called Greentrips with locations. So then this is just using the SQL display function that we got up here from registering our magic special SQL magics. So SQL display just means that it's going to convert the results to a pandas data frame, so it can be prettily displayed or further processed. So it's pretty awesome. It's a nice way of interacting with this. So we can see that is it a net fair? I think that means that it's greater than 0. So it's just somehow there's money being made, and it's not just a negative value, which I don't know why there would be negatives, but there are. Maybe refunds. So quartiles by total revenue. So now we can actually start to break it up and look at quartiles by the total amount of those. So now we're going to start using some pretty fun stuff. We're going to use the entile function, which is a window function. So we're going to partition by nothing, but order by the total amount. So now we're going to have 4 different quartiles. You can see, we can see some of those at least here. Oh yeah, we're only limiting it to 10. And so now we have that broken up into quartiles. And did I already run that? Yes, I think I did. Hold on. No, I did not. Quartile. Okay. So now I've got all these quartiles. They're dandy. It's going to sort by random because we like to use the random function a lot. Then we're going to analyze the revenue, tips, and percent of total revenue by quartile. And this just does a whole bunch of different aggregations. So this will give us, okay. So let's walk through this because I realized that this is an intro. I probably shouldn't just assume. So we're going to group it by the quartile. So we want to just break it down into the quartiles, 1, 2, 3, 4. Then we're going to call .ag. So this is an aggregate function. This is just telling Spark, hey, I've got this group by, and something to keep in mind with Spark is when you tell it to group by, if we just left it here, and in fact I can show you because this is a demo. That's the fun part about tuning in live is I can make a big fool of myself. So we can see that here that what gets returned is a group data. This is not very useful. In the olden days, you could actually get an RDD back and you'd have kind of a pair RDD to work with, but I'm not even going to go there because I'm just going to get onto a tangent. So this is one of the parts that you do more or less have to work within the PySpark ecosystem here in SQL because you don't really want to work with a group data object on its own. So anyways, once you have that, in our case, we're just going to do some aggregations, so we don't need to worry about trying to do something really custom or specific with our groups. So we're going to just get the total amount, the average total, the median total, because we like medians. I love medians at least. Average tips, median tips, average tip percent, and then just a count. So this is kind of a silly way to do a count, but it is the way that we have to work with Spark when we're using the API instead of the SQL queries. So this is just going to tell us how many trips total, and then the revenue that came from that, the sum of revenue. So we can get the total revenue by just looking at, so what this is going to do is going to take the data frame that's been aggregated, and it's going to sum up again, so we have the total revenue for all trips. Then by calling .first, we're just going to grab the first element of that result. So we can walk through this because again, ooh, I almost just deleted that. That would have been bad. So total revenue equals that. So let's just walk through this. So we have, say this, and we can look at total revenue, and we see that it's what it returns is we're just summing a double. So now we can just do a dot show on this, for example. And so we see that it's some big double. Then we can do dot first, and so now what we get back is we get a row back. And so this is cool because now instead of working within a distributed data set and DataFrame, so if you'll note, hold on. So let's just go through this. So quartile.dfs, the aggregated version has, oh yeah, oops, sorry, it only looks at the last evaluated. So the quartile.df ag only has 4 rows. But Greentrips with locations has like a couple million rows, I think. Yeah, oh no, not even. Just shy of 1 million rows. So that's cool. So now what we're doing here is we go from, actually we can just use this one. I think that might be a better demonstration. So we have total revenue. That comes after. We started out our structure here. The first one here is quartile DF. That's right here. Now that is just all of our rows with all the columns from our original Greentrips file, plus assigning the quartiles through the window function. Then, so that still has 972,000 rows. Then the quartile DF ag is going to say, I want just to look at it from an aggregated point perspective of by quartile. So I only want 4 rows in the output because there's only 4 quartiles. Then the next one's going to say, now I just want the total revenue from this, and we're going to only grab the actual value out of there. So we're going to look at the total revenue is going to print out at the end. So we have 907,000 rows, then 4 rows, and then the aggregate of how much total revenue is there is 14.18 million. So cool. We have all of that fun stuff. Then we're going to, at the end, this is the critical part here, is we're going to take our quartile data frame that's been aggregated by quartile. So it only has 4 rows. We're going to grab all of the values. That's what select star does. It's kind of a fun way, just like you're used to in SQL. Then we're going to round, and because we're going to take the revenue that we get from quartile DFAG. So now it's going to be, say, revenue right here, like 1.57 million is what this value would be. Think of it as that. So this is 1.57 million divided by the total revenue. So this is a literal. The total revenue is 14.2 million. So what we just said was 1.57 divided by 0.1. And so we get 11.10%. You'll see that's what we get here. So that's how we're getting to revenue percent. Oh, cool. There are people awake and following along. Sweet. Good. I'm glad to see that. Now we have now we have this whole data frame. We have the quartile with averages, medians, total trips. So you'll see that this actually split really, really nicely into quartiles, which is awesome. Not to say I would expect it to do anything else, because it really should. But it's really nice to see that when the data gets validated. And then we have the revenue, and you'll see obviously that the higher the quartile, the higher the revenue, because by definition we're splitting quartiles based on the total amount of the revenue. So some people in the lower quartiles probably just go on a couple blocks. Others are probably going across town. And then we just convert this whole thing to pandas so that we can use the fun display function, which is cool. Whew. All right. Then we group by hour. So let's do group by hour. I don't know what this does offhand. Let's see. So we're only looking at those times, which I thought was all. Oh, okay. So we're only looking at 1 day worth of data here. and we're going to group by the window. We're going to look at a window. So this is funny because this is actually a different concept. Okay, so I did some somewhat crazy stuff in this code base for being an intro. But I figured that hopefully everybody really likes to do fun and useful things. So the f.window is a totally different concept from a window function. It's silly, but it windowizes or bucketizes, if you will, so that all of your data is split up into those discrete time periods. So we're going to work by, so now we have a pickup window. So things that took place between midnight and 1 a.m. is one pickup window, 1 a.m. and 2 p.m. another one, etc. So it's cool. It's a very useful feature. I always have to make sure that it's explained that f.window is very different from what we used above, which is the window, which comes from here, way up here. That's right here. So window, just on its own, when it's with a capital letter, is from PySpark-SQL window. The f.window is from the PySpark-SQL functions .window. Very different, but they both do their own very useful things. So now we have pickup windows along with counts, and we're going to sort it by pickup window, and we're going to create it to 2 pandas. Then this is where the demo gods, I'm going to see, ooh, they are on my side today. They're even more on my side than when I last did this presentation. That's awesome. So now let's see, now you can see, thank God I'm actually using my own notebook because I had a problem when I ran this in Azure once, the Azure notebooks. So now we can actually see what hours of the day have the most pickups. It looks like 3 a.m. was just not a popular time, but 6 p.m. was off the charts. And we can see that midday was pretty steady. That's cool. And then, of course, because we're using Plotly, we get lots of fun features so that we can like zoom in and really just look really closely, because that's just some cool stuff. I truthfully don't use Plotly enough. Oh, geez, that was not what I wanted. Toggle spike lines, auto scale. Yeah, that's what I want. So yeah, cool stuff. We can plot it out. I think I got a little bit. I think this is why we did some of the fun stuff up here. This is why we did it. Is so we could put it into the format that Plotly needed, so we could see in this really pretty bar chart what's going on. So now let's say that we're a driver and we want to look at the tip percent by hour, because we want to maximize our own income. So then we can, sorry, hold on, trying to figure out where I am. Okay. So what this chart is going to tell us is what's the average tip percent on this specific day. And obviously this is, we're doing data science here, where we're going to try to figure out exactly, because this is an intro to PySpark. So let's bear that in mind, because I'm sure there are definitely better ways to go about this if we want to take it a science approach to really maximize our income. But we can see that, fascinatingly, the best times to get the most tips are actually midday, like later morning. I guess those early morning folks, even though they don't make up a lot of the traffic, because that's 4 a.m., 3 a.m., they don't tip very well. So that's kind of rough. They're making the drivers have to work that early in the morning and yet not tipping very well. But the people who ride at 10 a.m. are tipping at 8%, big spenders. And the people who ride at 10 p.m. So funny enough, both the 10s of the day, apparently that's when to be a driver. It's about 10 a.m. and 10 p.m. to make the most percent back as tips. So then we can just look at it also as a pandas data frame, and we can see the same exact data as we had above. But now we're going to do some new fun stuff. So now we can look at the pickups and tip percent by hour and see how well they correlate. So we can figure out when is the absolute best time to drive to both maximize the number of pickups that we can get and how much, and to maximize our tip percent. So that shows us now we have the same graph will give us both information. So now we can see that our 10 a.m. slot, there's 1,661 pickups at 10 a.m. So that's pretty good, an 8.05% tip. Then we bounce over to 10 p.m. was the other one that we liked. But you'll see that now we can see maybe there's a little bit less. There are fewer pickups for how much that they tip. So in our case, we might actually be more inclined to want to drive during the rush hour, of course. But this is questionable. You might almost argue that the better time to drive, because you can get still similarly good tips, but also have more pickups, is actually at around 7 p.m. because now you're going to be fighting with traffic a lot less, but you're going to be making the same amounts. You might be able to pull off more, get more passengers, and make more money that way. Okay, so we've done all sorts of fun stuff, and we can, of course, zoom in here and look. Wow, that was a totally useless zoom in. I'm sorry. We can totally just zoom in here and look at it in a more useful way. So we're looking at like more common times and all sorts of fun stuff. Another concept here are accumulators. I don't recommend using them much unless you really have a need for accumulators. Oh. What accumulators do is they give you a way to keep track of like what you're doing from a numerical perspective over the whole cluster. So normally you can't really look deeply into what's running on an individual level to figure out like how many rows you've looked at of anything specifically at the task level. So accumulators give you a way of just doing a sanity check. So in our case, we're just going to create an accumulator, and each time we iterate over the row in Spark, so revenue by hour.forEach, and then we're going to create an anonymous function, and we're going to add 1 to our rows accumulator. So let's say, and then we're just going to print it out. So we can see we iterated over 24 rows because we see that our accumulator returned 24. So did our data frame when we did a DataFrame.count. And so what this would tell you is if you had problems with your code or your cluster or anything else, if the accumulator rows came up at like 30, but your data frame row count was 24, that means you probably had something like a task failure where at least one of your tasks within Spark died. And so it had to be rerun. And so that accumulator would keep getting updated. So say it read 6 rows in, and then it wrote out, it accumulated with 6. Then the data frame, that task failed, and then it got rerun and it accumulated 6 again. So that's why you got to 30. So now if these numbers differ, because you know what the expected value should be, the expected is 24, but if the accumulator returns something different, then that might indicate you have a problem within your actual code or somewhere else that's causing an issue. But I don't think many people, you're not going to probably use accumulators much. I just put this in here because it's good to have in mind. So I think what's more relevant here that I'd like to spend some more time on for sure is, hold on, make sure, okay, is just talking about Python-specific advice. So my blog post, I have a whole dedicated blog post from January of this year, of 2018, to talk all about scaling Python for data science using Spark. I have a very similar talk coming up in June of 2018 at the Spark plus AI Summit in San Francisco, put on by Databricks. They're the creator of Spark, basically, that came out of UC Berkeley. And they have about, I think, 80% of the Spark committers on their staff. So they're a big part of what keeps the community going code-wise. So anyways, my blog post here covers the topic of scaling Python for Spark. But the gist of it is, or some part of the gist of it is, just avoid Python-based UDFs. They don't run very well. You want to use PySpark APIs, like PySpark SQL functions, so you can get the JVM for high performance. You can read all my stuff. I don't really feel like continuing to read this stuff, but basically with Spark 2.3, which came out now in on February 28th, I'm going to put that out on 2/28/18. Okay. Vectorized UDFs are supported. And so you can actually look at Databricks' description. So it tells you all about pandas UDFs and walks through them. And so then we'll just scroll down to the chart because the charts are fun. You'll see the performance comparison. So say CDF, you can see that before when we did row at a time UDFs, it took 242 seconds versus Panda's UDF version of the same thing, 1.1 seconds. Subtract mean, 117 seconds, 7.2. So it's a pretty good motive to use PySpark UDFs. And because you're watching this, you probably do care about PySpark, where you're going to be using Python functions more. Totally worthwhile to look into 2.3 and beyond, of course. It should continue to get even better. I also wrote a post that I didn't note on here that talks about my own lessons of using PySpark UDFs. It's right here. The long and short of it is it wasn't as good as I expected it to be. But I also only did this as a really basic test. I was just a little bit surprised. But I'm not going to get into that. So then what I show here is the Spark way of doing it with PySpark UDFs. No, hold on. Sorry. No, this is the Python way of doing it because I have a Lambda function, my anonymous, and then I'm going to select and just get that value back. So let's let that run for a little bit. It'll take a little bit longer, of course, because it is using Python UDFs or Python code specific UDFs as opposed to PySpark SQL functions, which are higher performance. But you will note that, of course, you have to define the UDF using f.udf, and then this is the code that we're passing in. You can also write the code like just a regular function, like 2 times down, whatever, and then pass that into f.udf. It's just I did this for the sake of brevity. Blah blah blah. So that will run. Both of those will run. The next point is be cautious about using your favorite Python packages with Spark because most code, if not all of it, basically in Python, is used to executing only on one machine, the driver, in the Spark cluster, using just a single core while Spark is distributed. So you might have a cluster that has 50 nodes and each one has 8 cores. So you're talking about 400 cores that are dedicated just to you running something in Spark. But then you pull in something like pandas or NumPy, and if done incorrectly, you're going to be running that code on 1 core on your driver node, as opposed to 400 cores spread out throughout the cluster. So the long and short of it is you probably can use any package you like, but just because you can doesn't mean you should. Just be careful. It's not a hard and fast rule. You don't have to follow my advice, but just bear that in mind. And don't use RDDs. I think this is an even simpler piece of advice. Because if you use RDDs, you're just going to get into hell, especially with Python. Python and RDDs don't work well. You want to use Spark SQL, where Spark SQL is not just the SQL queries, because DataFrames are part of Spark SQL. They're in that same namespace of PySpark.SQL. And with SQL and everything inside the DataFrames datasets, Catalyst and Tungsten are the 2 optimizers that come into play so that you can get a lot better performance. Catalyst will keep track of how well your performance is, or it'll keep track of your queries and try to optimize them so it'll run as quickly as possible. And Tungsten will do some whole stage code generation and memory optimization to keep your footprint low. I did have a whole different talk on that at one point, so you can look all the way back to July of 2017, and you'll see using Spark efficiently, where I have slides that talk all about Catalyst especially, but a little bit about Tungsten as well. Because those are really critical. Those are the pinnacle of why Spark is so fast, especially with data frames and data sets as opposed to RDBs. Also, when I was talking, because I've been talking a lot, if you couldn't tell, this code finished where we ran it with a Python UDF, and you'll see that took 2 minutes and 19 seconds. And then I ran it with the PySpark SQL UDFs. That's 5 seconds. So you can choose. Do you want it to take 140 seconds or 5? I think most people, with a few exclusions, strange ducks, if you will, would want it to take 5 seconds. So use that, PySpark SQL functions. Let's just go through real quick because we only have a few minutes left. Some common problems. If you try to call it and the file doesn't exist, Python and Spark will tell you that. It'll say that path does not exist, so don't do that stuff. Don't use truckloads of small files because it's death by 1,000 very slow cuts. I crack myself up sometimes. The wall time for reading 1,000 files was 1 minute and 7 seconds. It's much faster when you use the bigger files, but not too big. And this is what I was talking about also. I actually did some pretty good job putting all these notes in. That's awesome. Yay me. So gzip is not splittable, therefore cannot be parallelized across a cluster. So don't use gzip or use it and then be efficient about it. Just be wise. I'm trying to make your life as easy as possible or as pain-free as possible, because these are a lot of lessons I've learned over the years of working with data. And then the most basic incarnation of reading CSV files, every column has a generic name and is of string type. Don't ever do this unless you really like to cause yourself pain, because this is what it's going to look like. Now you have, I'm a big fan of underscore C3. That's really just a great column. It has such useful value in it that I go home every night and I'm like, I really just want to talk to underscore C3. Sorry, dad joke. Bad joke also. So whatever you do, don't use without the option header and the option infer schema ideally, but option headers obviously even more important, because if you don't have the header, then you're just going to end up with generic column names, and that's just hideous. Okay, now that it's been a long time and that you've had to listen to me, I can answer questions if you guys like. Otherwise, we are going to be done. So the first question I see here, in what scenarios would you recommend to not use PySpark, Spark in a Python project? If you don't have lots of data or you don't have a lot of processing to do, I don't see why you should need PySpark. Also, is there a way to modify how tasks are distributed among the cores? Hold on. Okay, one thing at a time. So if you don't have a lot of data or you don't need parallelized processing, so there is a case where you might want PySpark. Let's say you want to do some machine learning. And I'll give you a real use case that I've had. Some time ago, I had some data science colleagues at a previous employer who were trying to train machine learning models. And their training, they had to work on I think like 100 megabytes or something worth of data, and it took hours to train their model. I came in and trained basically the same model even more thoroughly, complete with cross-validation, random forest regression on the entire data set, which was multiple gigs, in seconds. So there are cases where you don't need a lot of data to justify using PySpark or Spark in general. And that's things where you have a heavy amount of iteration and a heavy amount of processing in general. But in most cases, when you're using Spark or PySpark, you do want to have the most amount of processing possible, or most amount of data possible to work with. because that's where the vast majority of use cases come from. Is you have terabytes, petabytes worth of data that you need to process in some amount of time. And an increasingly common use case, like I'm going through, and I've been going through for some time, and I really like this use case, is streaming. And another choice, of course, with streaming is not just Spark structured streaming, which I do recommend. I've used it, it's pretty fun. But also Apache Flink is another project that also works with streaming quite well. Okay. Hopefully that answers the question of when I would recommend to use it and not use it. Is there a way to modify how tasks are distributed among the cores? Yes, to a large extent, yes. The way that you do that is, let me look for it in here. The primary way, oh, here we go. So I would say this is a good reason for why you might want to redistribute. So let's say you read in this big gzip file, and somebody gives you this gigabyte gzip file, but you want to actually run this in a distributed fashion. If you run it normally, Spark is going to just read in the one file, and it's going to take a long time. And you're going to have to suck up that cost. That's just part of life. You have this gzip file, it's going to be slow to read in. But you can then do a repartition on the resulting data frame, which will then shuffle the data across the network to each executor, so think of partitions as being more or less synonymous with tasks. If you have only one partition, because you only have one file that's gzipped, that's only one partition. And so now you can repartition that into, say, 32 partitions, and now you will have 32 different tasks that you can run in parallel. And I think that's it, unless there are questions. Any more questions? And hopefully that answered your question, Shilpa. Heavy, large amounts of data. It's good for Spark. Large amounts of data processing. Spark. Data plus processing equals overhead low slow. Oh, well, that was a silly comment. Now I didn't realize that would print like this. Okay. So with that said, thank you all for attending, and feel free to connect with me on LinkedIn or hit me up on Twitter. Email me if you really like, but visit my blog and play around. And let me know if you need any help specifically, and I'm happy to chat. But I would definitely recommend, if you care a lot about Spark, really go deep into my blog, because I am a Spark specialist. I do this stuff all day, every day, and have for years. So there's a lot of content on there. I don't have any monetization on my site, so if you're worried about I'm trying to just make money off you, there's none of that. I am just trying to provide the information. Probably should put something on there so I don't just spend money and time on all this. But here are the huge amount of resources that come with the Intro to PySpark class that we just had, including all the different books from the true masters of Spark, the articles and blog posts, including my own, because that's funny, because I would of course put my own in here. The notebooks, repositories, presentations, and free notebooks of ways you can do it, including the Azure notebooks. You can use Databricks Community Edition. You can even use that Docker image if you really want to go fancy and put your pinky in the air. Okay. So thank you again for attending, and I hope you got something out of it. Have a good rest of your day.